Welcome back to my YouTube channel. Today's session we are going to learn about steam turbine systems. I will tell you about different scenario based questions, how you can prepare about the steam turbine, and I will also share you the notes where you can prepare in depth about the steam turbines, its types of turbines, how we are selecting the blades, all of these. I have prepared few questions, a few very short questions, but very important regarding to the interviews coming. Your GTS programs are MTOs. You can prepare well from that. So let's start from the basic steam turbine design. You have to know about. You can read all of these, which is turbine classifications, uh, types of compounding, velocity compounding, pressure compounding, and pressure velocity compounding. You have to know about all of these terms, and then types of steams. You have to know types of steam. There are three types of steam actually. You have to know about that: saturated steam, wet steam, and superheated steam, which is dry steam. You have to know the sensible heat and latent heat of vaporization. You have to know about that. What's the purpose of that, and what's the purpose of enthalpy in steam turbine, in superheater, its main function. You can write in the comment section. I will tell you about any question regarding anything. Next, you can learn about high pressure turbines, low pressure and high pressure turbines. When we are using high pressure and when we are using low pressure, and which type of turbine we are using. I have shared all of these things here. You can read and get ideas how engineering is working in steam turbines. These all things are not mentioned in any books or any textbooks. Actually mentioned, but they in classroom studies these things are not covered up. So you have to read up all of these things here. I have shared you these things. You can read up by stopping the video and understand the basic behind there. I can just give you one thing about types of compounding, which is very simple and important, which is velocity and pressure compounding. In pressure compounding, actually, we are covering all the pressure to convert it into the nozzle at the turbine, which is in impulse turbine, and then we convert it uh, the pressure energy of into the kinetic energy, which is in term of velocity, and then in every stage we are dropping that velocity and converting it into mechanical energy, while in the we can say in the velocity compounding steam turbines, we at every stage, if velocity compounding is approximately as a reaction turbine, and we are converting every stage its pressure into kinetic energy. Every stage pressure is dropping and kinetic energy is increasing and then dropping. Okay, and there's a simple concept of the pressure compounding and velocity compounding. Here is, these are very simple way I have presented here. You can get ideas of how turbine section is working. But today's session we are going to discuss is about the simple and most important questions of steam turbines. So let us start about steam turbine. First of all, what is a stage in steam turbine? You have to know stages mean a number of blades in steam turbine which are moving continuously. In impulse turbine, the stage is a set of moving blades behind the nozzles. In a reaction turbine, each row of blade is called a stage. Okay, you have to understand. Like I can share. mm Here, no. Single cutter stage may consist of two or more rows of moving blades. You have to know a stage means a stator, fixed blade, and a moving blade. We can say combinedly that into one stage. There are multiple stages of steam turbines. That's all depends on our requirements. Okay, next one is what is a diaphragm? A diaphragm is a means stators, fixed blades, partitions between the pressure stages in a turbine casings are called diaphragms. In two stages, in between two moving blades, there is a diaphragm which is fixed blades. This holds the vane shape, nozzle, and seals between the stages. Actually, above that, uh, our diaphragms or fixed blades are fixed to the casing, and below that there is labyrinth seals on which it is staying. Actually, that's happening in the turbines. One half of the diaphragm is fitted onto the top of the casing and other into the bottom on the labyrinth seals. What is next one is what is the radial flow turbine? In a radial flow turbines means steams flow outward from the shaft of the casing. Means steam outward direction moving towards the casing shaft toward the shaft of the casing. Okay, this the unit is usually a reaction unit having both fixed and moving blades. These are used for special jobs and are more common to the European manufacturers such as Stalavel, now ABB. Next one is what are four types of turbine seals. Actually, in turbines, we are using mostly uh, three types. I can just say two to three types. Labyrinth seals, mechanical seals, and these are the main types of mechanical seal, which is carbon rings, and these are same, and we are using in the turbines and also used in the pumps sometimes. The carbon rings fitted in segments around the shaft, which held by the garter and the retainer springs. Labyrinths mated with the shaft serrated or shaft seal strips. Water seals, where a shaft runner acts as a pump to create a ring of water around the shaft, use only treated water to avoid shaft pitting. Water seal. Sometimes this is not used, but mostly we are using labyrinth seal than mechanical seal. Actually, labyrinth seal we are using in the steam section areas, while while a mechanical ring, a carbon ring is used to separate the steaming section from the oil rings. We can say oil sides. These are separately sections. Stuffing box using woven or soft packing rings that are compressed with a gland to prevent leakage along the shafts. These are simple four types of steam turbine seals, but actually I know the two types. I just want to say lab seal and mechanical seals, but I know stuffing box and water seal in used in pumps, but these are not used in turbines. I according to my concept, in which turbine is tip leakage a problem. Tip leakage is very important in steam turbines. It actually causes recirculation, and it uh, it drop the pressure in the turbines, and it's actually happened in the reaction turbines, not in the impulse turbines, because impulse turbines steam is converted pressure into kinetic energy at the first stage of the nozzles. Next one is here each pane from a nozzle steam must flow through the moving blades to the fixed blades. Steam accepts escaping across the tips of the blades represents a loss of work. Therefore, tip seals are used prevent this. There are two types of clearance the turbines. In turbines, one is radial clearance and one is axial clearance. These are the two types. Radial clearance is between the router and the casing. We can say above blades are moving and the casing minor 3 to 4 mm clearance we are giving in the steam turbines, while axial is the fore and aft clearance and the side of the rotor and the casing. Actually, radial clearance and axial clearance are very important. Without that, friction losses, friction increases, and heat in the rotor, in the shaft increases, and this causes thermal expansion in the shaft of the turbine. Next one is what are the four types of thrust bearing. Thrust bearings, which are controlling the thrust produced by the steam hitting on the blades, and that for that we are using thrust bearings. Actually, uh, few turbines uses simple tilting pads, and sometimes they are using tapered land bearings, but most of the time they are also using white metal bearings, white metal for the controlling the thrust. All of these are used. These are the mentions here: babbitt face collar bearings, tilting pad, pivotal pair pads, tapered land bearings, rolling contact bearings. These are four types of bearing thrust are used in the turbines. Next one is what's the function of thrust bearing. Thrust bearing is to control the thrust produced. To control means absorbing and providing the reaction to the force coming from the rotor side. Okay, actually there are thrust and journal bearing used in the turbines, but these four types we are using only in single one the turbines. Okay, what is a ballast piston? This is not very so much important, but you can read up that. Next one is, why should a steam or moisture separator be installed in the steam turbine next to the steam in the steam line next to the steam turbine? Basically, we we are very conscious about the wet steam. We are not allowed it to enter into the steam section, into the turbine section. Sorry, in the turbine section, because it will hit the blades and cause erosions, because wet steam can cause corrosions, erosions, anything else here. So we have to remove any wet or any water in the steam. We have to provide fully saturated, fully superheated steam to the turbine. For that, we have placed flask vessel type vessel before the steam, before the main stove valve of the turbine, where steam hit directly onto the on the baffles inside the vessel. So steam when hit, water drop and steam then flow outside of that and into the line. This is a simple concept I have to tell you about. Next one is, what are some conditions that may prevent a turbine from developing full powers? Uh, According to my knowledge and my concept, and I am not reading all of these, I have written that, but I want to share a few things regarding why turbine is not developing full power. There are few reasons. Number one is your stainer. If it is it if it has any sludge, any dirt, or any corrosion etc on that, and the block and the incoming section is blocked, steam is not coming to the turbine, then your turbine will not give you the full power. That was the main reason. The second one is the if your uh, I can say steam pressure is not maintained. If your pressure is not maintained, then you will not get the turbines uh, at develop the turbine full pressure. Then next one is if governor is not set, if governor pressure is not set, means your governor is not operated at rated pressure. Like my turbine is working at 8 kg per centimeter square pressure. If this pressure drop or high, then there is surety that turbine is not fully full powered performing. So we have to make a set pressure which is given by the designer manufacturer. We have to provide that to the oil to the lubricator lubrication pressure. Then next one is the, you can read just there uh, few things here. The machine is overloaded. That's fine. Machine if it's overloaded, then turbine will not go to the full power. We have to cut off, and then we have to maintain it full load. And then the steam pressure and temperature not up to the design. That's we are covered. The exhaust pressure is too high. Yeah, if exhaust pressure means high, it means we are losing, we have lost our power, we have our energy to the steam that we have to convert in the steam section areas in the blades. So we our main concept is we have to cover maximum its energy, maximum enthalpy, maximum internal energy of the steam into mechanical energy at the steam section blade areas. We are not giving it go through the out exhaust section area. We have to make negative pressure at the bottom, so we can cover all the chemical, all the thermal energy into mechanical energy. Okay, next one is steam governor is set too low, steam press trainer is clogged. Okay, nozzle pressure are clogged with deposit. Okay, that's fine. All of these internal wear on the nozzle and blade. Why it is necessary to open casing drains and drain on the steam line going to the turbine when a turbine is to be started? That's very important. When we are starting our turbines. So the answer is here is to avoid slugging nozzles and blades inside the turbine with condensate on startup. Okay, that can break these components from impact. These blades are designed to handle steam, not water. Actually, we have discussed above, we are not taking wet steam into the turbine section. This will cause severe reaction on the turbine, and we can't handle that. What is steam rate as applied to the turbo generator? The steam rate is the pound of steam that must be applied per kilowatt hour of the generator output at the steam turbine inlet. Next one is, what are the two basic types of steam turbines? The steam turbine impulse and reaction turbines. Next one is, what is operating principle of an impulse turbine? The basic operating principle of an impulse turbine is that a jet of steam from the fixed nozzles uh, coming out, and all its pressure energy is converted into the kinetic energy, into the velocity, and that hits the plates and convert that kinetic energy into the mechanical energy. That's the main simple principle of the impulse turbines. Why? If you like that videos, if you like concepts, if you want more, I will share you about more in-depth questions about the steam turbines, troubleshoots, their operational point of view, their maintenance, their scheduling, their planning, how we are planning when we are outraging our turbines. I will share all of that next to my videos. So please like, share, and subscribe my YouTube channels. It will help me a lot. Thank you so much.